Hi everyone, this is Mr. Finn. I'm here to take you through 6C.3 for pre-calculus. Hope you guys are staying safe out there, keeping your hands washed, keeping the house clean, and taking care of yourselves while we're on this little bit of a break. Do me a favor, go ahead and make sure your phones are in your phone home. I'll give you guys a minute. Okay, good, thank you. So today I'm going to teach you about applications of vectors. So some things that vectors are really used for is in the physics world when we look at different forces acting on an object. So I'm going to walk you through the different steps to complete this. My suggestion for you would be as you're doing this, pause the video as you see an example. Try the next one just like you would do in class, and then restart the video just to see how you did. So when we have two forces acting upon each other, we're going to look for a couple of different things. We're going to look at both forces and we're going to get it into its components. Those different components would be along the x and y axis, okay, for both forces. We're going to get it into terms of cosine and sine. So, when we talk about horizontal things, that always has to do with cosine. Okay, so we're going to be using this here. When we talk about anything vertical, that always goes with sine. So we're going to be using this one here. Other things we're going to find the resultant. By adding the two vectors together, we're going to find the magnitude, which is the distance formula, and then we're going to find the direction. So we're going to find the angle of the forces. All right, so starting off here, we have a ship traveling at 23 knots at an angle of 17 degrees with the current. For anybody that knows me and has me in class or has had me before, I'm an excellent drawer. So there is the current. Here is the ship. So current is going into this direction. Ship is going off into this direction. Okay, so here's what the boat is doing. It is traveling at 23 knots. It's traveling at 17 degrees. Okay, and here's the current. So let me just bring this over here. So again, here's the current. Okay, here's the ship that's traveling at 23 knots. Okay, and it's at a 17 degrees that it's traveling in. Okay, so these first couple problems are just having you do a couple of sketches before we go into actually finding all these different components that I talked about. So again, this is a great time to pause the video, try to sketch the next one, and then start it off again to see how you're doing. Okay, so for the next one, you have a force of 56 newtons acting on an object at an angle of 67 degrees with the ground. Okay, so here's the ground. Here's the force at 67 degrees. Okay, and that's 56 newtons. All right, so we're going to move on. We're going to find the magnitude and the direction of the resultant vector for each diagram. So here's we got two forces going on. We got one force at 300 newtons. We got a second force at 170 newtons at 55 degrees. So force one. Actually, make it a different color. Okay, so force one, we're going to set up the vector of the force with the horizontal component and the vertical. Okay, so we'll call this one up here force one. So when we look at this, the force of it is 170 newtons. The cosine of this is going to be 55 degrees. Okay, and then for sine, 170 sine of 55 degrees. Go to your calculator, make sure your calculator's in degree mode, not radian mode. Calculate these things. So when you take 170 cosine of 55, you're going to get 97.5. When you take 170 sine of 55, that's going to be 139.3. Okay, so this is the component, okay, for the first vector. Second vector. Okay, so force 2, force 2. Set it up the same way. Okay, now the newtons are 300. And we're going to do cosine of 0 degrees because this is laying flat, like on the ground. Okay, then we're going to take 300 sine of 0. Throw this in your calculator. We get 300 and 0. So first thing we're going to do is we're going to find the resultant. Okay, to find the resultant, we're going to add the vectors. Okay, so we're going to add the x components, we're going to add the y components. Okay, so the resultant for this is going to be at 397.5 and 139.3. Always a good idea to kind of think about what quadrant this is going to be in. So since we have a positive x and we have a positive y, this means it's going to be in quadrant 1. To find the magnitude, we're going to take these two things and we're going to plug it into our distance formula. Take those, put in your calculator, and we're going to have the magnitude, which is now the force in terms of newtons, at 421.2 newtons. Direction of this, using tangent. Okay, so let's go ahead with tangent inverse. Okay, I have opposite over adjacent. So 139.3 over 397.5, which is at 19.3 degrees. So when we look at these two forces acting upon an object, what it does, okay, it puts it somewhere in between the two forces. Okay, so when both forces are acting upon it, it's now got a total newtons of 421.2 in that direction of both of them pulling on it. One at 0 degrees, one at 55 degrees, is now at 19.3 degrees. Now's a good time for you guys to pause this, okay, and check out the next one. So for the next one, set it up the same way. We're going to go ahead and we're going to put both forces in for it. So we have 50 newtons, we have 65 newtons, we have that angle in there. Okay, we'll talk about how we're going to put that in. So let's go ahead and start with force 1, which I'll call this one right here, force 1. So this is going to be 50 newtons cosine of 255. Okay, and then 50 newtons sine of 255. I apologize, I'm not writing very small like I normally do, so I'm going to do that one more time. Okay, so force 1, 50, cosine of 255, 50, sine of 255. We always want to think about standard position for this. We want to think about going counterclockwise. So we're going from here to here, okay, into force 1. Force 2 is going to go from here to here, over there. So we got to think about what that angle is. Okay, so force 2 for this, 65 newtons. Okay, but when I do the angle for this, I have to add the 255 and the 60 degrees to this, and that's going to give us 315 degrees. All right, so let's go ahead and calculate these. So when you take 50 cosine of 255, that's going to give you approximately negative 12.9. And then when you do 50 sine of 255, that's going to be negative 48.3. For force 2, 45.96, negative 45.96. All right, so to find the resultant, we're going to add these two things together. So the resultant for this is going to be 33.06 or 33.1 if you want to round it up. Okay, and then the y component for this is going to be negative 94.2. Okay, let's go ahead and go into the magnitude. Okay, so the magnitude for this, we're going to take those two items, plug them into the distance formula. Okay, that's going to give you 99.83 newtons. Okay, so we have this, which by the way, when you have both these newtons, the resultant of this, this is going to put you in the fourth quadrant. Okay, something to think about when we find our angle here. Okay, so we do tangent inverse. Okay, we're going to take the negative 94.2 over 33.06. And that's going to give us an angle of negative 70.7. So we got to think about what quadrant we're in for this. So this is going to put us into the fourth quadrant. So we're going to take 360 degrees minus the 70.7, and that's going to be roughly 289.3 degrees. Okay? All right, let's take a look at a couple more examples. Okay, so we have Denzel. Denzel pulls a wagon along a level ground with a force of 18 newtons on the handle. If the handle makes an angle of 40 degrees with the horizontal, find the horizontal and vertical components of the force. You can draw any picture that you want. I'm just going to keep it simple here. Okay, so we have a horizontal component. Okay, and then we got the handle that's going up like this, and this is at 18 newtons. and it's a 40-degree angle that it's making with the ground, with the horizontal force. So let's go ahead and let's find the x value for this. Okay, so x is going to be the force cosine of theta. So the force is at 18 newtons. The cosine of this is 40 degrees. When you plug that in your calculator and you calculate it, this is going to be 13.8 newtons. The y component to this, the force sine of theta. So y equals 18. 18. All right, so plug that in. Okay, and y is going to be 11.6 newtons. All right, getting it so far? All right, last one. Last one, we're going to talk about equilibrium. Okay, so a 33 Newton force at 90 degrees and a 44 Newton force at 60 degrees are extended on an object. What is the magnitude and direction of the resultant vector that produces equilibrium on the object? So first, let's just draw this out. Okay, so we have two forces. Okay, we'll call this one force 1. Call this one force 2. Put some information in here. So this is 33 newtons. This one is 44 newtons. All right, so the 33 Newton force has a 90-degree angle associated with it. Okay, right down here. Okay. The second one has a 60-degree angle. So right here. Okay, so again, we're thinking about this like in terms of the ground. So let's go ahead and calculate force 1. Okay, so force 1 of this is 33 cosine of 90. Then 33 sine of 90. Go through, we calculate that, put in your calculator. 0 and 33. Again, now's a great time to possibly pause this, calculate force 2, restart it, see if you got the same numbers. Force 2 for this, 44 cosine of 60, 44 sine of 60. Okay, throw in your calculator if you haven't already. 22, 38.1. Okay, so let's get the resultant. Okay, add them both together. So this gives us a resultant of 22 and 71.1. Okay. Try to find the magnitude. So magnitude, square both of these. Okay, then take the square root. The magnitude is about 74.4 newtons. Okay, then find the direction. The direction is going to be tangent inverse of 71.1 over 22, which is 72.8 degrees. Okay. So, big thing to note here, again, what quadrant this is in. This is in the first quadrant. So we talk about equilibrium, we talk about how this is like balancing out. Okay, so if we think about the direction, if we think about the newtons and everything, it's going to put us somewhere like this. Okay, so we have a 72.8, 73 degree angle. The newtons, 74.4 newtons. We talk about equilibrium. Again, we talk about a balancing. So that means the equilibrium would be a straight line going off into the other direction. The force of this equilibrium is the same as the magnitude that we just calculated. Of 74.4. The direction of this. So think about what quadrant this is in. If I have a straight line and I was just in the first quadrant, that means the direction of this is going to be in the third quadrant. So since it's in the third quadrant, we're going to take the angle that we just had, the 72.8, and we're going to add on 180 degrees. Because everything in the third quadrant is between 180 to 270 degrees. So we're going to take the 72.8 degrees plus 180. Okay, and that angle for equilibrium is about 252.8 degrees. All right, so that is applications of vectors, the 6C.3. If you have any questions, please reach out to myself, Mrs. Bolin, or Mr. Rainsberg. Thanks a lot, and stay